In this video, we're going to look at how the arithmetic in the complex quotient structure R mod I modded out by S mod I actually works. To get started, I want to remind you about what we know. We are assuming that R is a ring, and we're assuming that S is an ideal in R, and we're assuming that I is an ideal in R, and we are assuming that I is a subset of S. And under these hypotheses, the correspondence theorem says that the quotient ring S mod I is an ideal of the quotient ring R mod I. And so that tells us that R mod I modded out by S mod I is in fact a quotient ring. Now in the previous video, we found out that the elements of R mod I modded out by S mod I look like this. They look like little r plus I, and then we add the ideal S mod I, and this is where R is any element of the ring R. We also know one other thing from the previous video, and that is that R1 plus I plus S mod I is equal to R2 plus I plus S mod I in R mod I modded by S mod I, if and only if R1 plus S is equal to R2 plus S in the ring R mod S. In this particular video, I want to actually look at how the arithmetic in R mod I modded by S mod I actually works. So, if I look at R1 plus I, and I add S mod I to it, and I want to add that coset to the coset R2 plus I plus S mod I, what am I going to get? Now this particular thing is inside R mod I modded by S mod I. Well, since I'm in a quotient ring, I know how to add stuff. I simply add the coset representatives. And the coset representative of this coset is R plus I, and the coset representative of this one is, oops, that should be an R2. So let me make that correction. That should be an R2. And the coset representative over here is this guy. So the sum of R1 plus I plus S mod I and R2 plus I plus S mod I is going to be R1 plus I plus R2 plus I plus the ideal S mod I. Now, it's important to realize that this sum is inside the ring R mod I. And I know how to add two cosets in R mod I. I just add their representatives together. So I have R1 plus R2 plus I, and then I add that to the ideal S mod I. And so this particular guy here is the coset representative. In other words, he is an element inside R mod I, and this is the ideal that we're modding out by. So that's how coset addition is going to work in R mod I modded by S mod I. Well, what about coset multiplication? So let's turn our attention to that. R1 plus I plus S mod I times the coset R2 plus I plus S mod I inside our ring R mod I modded out by S mod I is going to look like this. Well, coset multiplication in a quotient ring is defined by multiply the two coset representatives together. So we're going to have R1 plus I times R2 plus I plus our ideal S mod I. Now, this particular multiplication is inside the ring R mod I. And I know how to do that. Inside R mod I, this coset times that coset is just going to be R1 times R2 plus I. But then we also still have to add the coset that we're modding out by in this quotient structure here. And so what we have is that the product of these two cosets is going to be R1 times R2 plus I plus the ideal S mod I. So this stuff here is the element in R mod I, and this is the ideal that we are modding out by. So to summarize what we have the following two facts. In R mod I, modded out by S mod I, if we want to add two cosets together, so there's one coset, and we want to add it to this coset, the answer is going to be R1 plus R2 plus I plus S mod I. And if we want to multiply two cosets together, so there's my first one, and here's my second one. If I want to multiply the two cosets together, I'm going to get R1 times R2 plus I plus the ideal that we are modding out by, which is S mod I.